Hello, everybody. For those of you that don't know me, I'm Mr. Huber, and today I figured I would make a quick video that went through some of the problems on your summative number 1 review. All right, so I think there's only 8 problems on that review, so we'll kind of quickly look at all 8 of those problems now. All right, here's question number 1. All right, in this one, we're going to be subtracting 2 different polynomials. All right, polynomials just deals with the number of terms. So see how this has 3 terms and this has 3 terms. All right, that's why those are both called polynomials. And we're going to be subtracting them. Whenever you're subtracting, okay, we have to remember that this minus sign is going to get distributed to all of these terms in your second polynomial. All right. So now I'm just going to rewrite this: x squared plus 4x plus 7. And now minus x cubed minus 2x. And now when we distribute this negative to the -3, a negative times a negative would make this a positive 3. All right, once we go ahead and distribute that negative, we're just going to look for like terms. All right, so I see I have this negative x to the 3rd power. So I'm going to rewrite that one first. I always like to put the highest degree first. All right, so I have negative x to the 3rd. Okay, next I'll look for any x squared. No other x squared, so I'm just going to write plus x squared. All right, then we'll look for any x's. I have a positive 4x here and a negative 2x here. So that would be a positive 2x. And last but not least, our constants. We have a positive 7 and a positive 3, which would add together to 10. All right, now this is as simplified as we can get this polynomial, okay? We can't add or subtract any terms that are to different degrees. So we can't add these two because one is x to the 3rd power and the other is x to the 2nd power. They can't have a different degree value. All right, let's look at number 2. This one's a little different. Okay, now we are multiplying. Okay, whenever you're multiplying, you have to multiply all of those parts together. So it might be a little bit easier for us if we first look at number 4. So let's go to number 4. Number 4, we learned FOIL. All right, so that stands for first, outside, inside, last. All right, so what that means is I'm going to multiply my first 2 terms. So 2x times x, and that will give me 2x squared, because x times x is x squared. Okay, first, then we want outside. So these outside 2. So I have 2x times 3. Well, 2 times 3 is 6x. And we want the inside. -1 times 1x would just be -1x. And then we want your last 2 terms. So -1 times 3 would be -3. All right, watch out, you're almost done, but we can combine this positive 6x and this -1x. So we would have 2x squared plus 5x minus 3. And that would be our final answer. So in this one, you can kind of see, each of those terms got multiplied by the other polynomial's terms. All right, so now if we go back up to number 2, that means that each of these terms has to get multiplied by all three of these. All right, so that would mean that your 2x is getting multiplied to all three of these. All right, so you have 2x times 3x cubed. So 2 times 3 is 6. And then we have x times x cubed would be x to the 4th power. Then we have 2x times negative x cubed, or we could say negative 1. So 2 times negative 1 would be negative 2. X times x squared is going to be x cubed, or x to the 3rd power. And lastly, we have 2x times x. So that's going to be 2. X times x is x squared. All right, but now we're not done yet. We also have to multiply this 5 to each of the terms in that second polynomial. All right, so we have to do 5 times 3x cubed. So 5 times 3 is 15x cubed. 5 times negative 1 would be negative 5, and then we have x squared. And then 5 times x would just be 5x. Now, you'll notice how I wrote these to kind of help me when I'm combining my like terms. See how I lined up my x cubes and I lined up my x squared? So now, when I go to simplify this, I have 6x to the 4th. Negative 2 plus 15 would be positive 13x cubed, minus negative 5 plus 2 would be negative 3x squared plus 5x. And this would be our answer for that number 2. Okay, we can't simplify it anymore, that's it. All right, then if we look at number 3, we actually get a little bit easier. We just have addition. All right, so when it's addition, we can almost treat this like one long polynomial. So 3x cubed minus 5x to the 4th minus 10x plus 1 plus 17x to the 4th minus x to the 3rd. All right, so let's go ahead and combine any like terms. I'm going to start with x to the 4th power. Ooh, I see this positive 17x to the 4th power over here too. So now I have 17 minus 5 would be 12x to the 4th power. All right, then let's look for x to the 3rd powers. I have 3x to the 3rd power, and this one over here would be negative 1x to the 3rd power. So 3 minus 1 would be 2x to the 3rd power. Next, let's look for any x's. I have just this negative 10x. And finally, any constants. We have just this positive 1. All right, so that would be my simplified polynomial for that one. Okay, now we're going to move into the second half of this review. And in the second half, we're going to be doing the exact opposite of what we just did. Okay, we're going to be factoring. All right, and when we factor, we're going to look for 3 different types of factoring problems. All right, first of all is when we just factor normally. Second, we're going to do factor by grouping. And third, we're going to do difference of squares. All right. So whenever you look and you see, okay, how many terms does this have? That's usually what I like to start with. All right, this one has 4 terms. Whenever there are 4 terms, okay, that usually means that we're going to do some factor by grouping. All right, so maybe we even want to write that after. 4 terms. All right, so what factor by grouping does is it says, hey, cut this in half. All right, and now look for a GCF in the first half and a GCF in the second half. All right, so I'm looking for a greatest common factor, or what could we take out of these 2 terms? All right, and both of them have 2 x's. So I'm going to take out an x squared so that this is just now 1x. And now this is just 5 because I pulled out that x squared. Then I look at the second half and I say, okay, what could I take out of both of these? And I notice, both of them could be divided by 7. All right, so I'm going to pull out a 7, which would make this x, and then minus 35 divided by 7 should be 5. Now, if you did your factor by grouping correctly, these should be the same. Okay, so then I just rewrite that in my answer, x minus 5. And now your other polynomial, in this case, is just going to be the 2 GCFs that you factored out. So x squared and a positive 7. So I'm just going to write x squared plus 7. And this would be your answer. Okay, let's look at number 6. Number 6, remember, we always start by looking how many terms does it have. This one has 2 terms. Okay, not only just 2 terms, but also subtraction. All right, whenever we have 2 terms with subtraction, we are thinking difference of squares. All right, so let's write that in there as well. Two terms and subtraction. All right, so remember, your difference of squares says that we can do the square root of both of these. So I'm going to do the square root of x to the 4th. So square root of x to the 4th would be x squared times x squared. And then we can do the square root of 16. Well, 4 times 4 is 16. All right, and then we make one addition and one subtraction. Now watch out. This one here, notice we have 2 terms and subtraction. Uh-oh, 2 terms and subtraction. That means we have difference of squares again. So that means that we can take the square root of both of these. So I have x squared plus 4. The square root of x squared would be x. All right, and the square root of 4 is 2, because 2 times 2 is 4. And we make one addition and one subtraction to cancel out that middle term. All right, and now this would be our final simplified answer. All right, so that one was a little tricky. It was like a double difference of squares problem. All right, always look for the number of terms. I see 4 terms. We already talked about 4 terms. Whenever there's 4 terms, we're thinking, oh, let's try to do factoring by grouping. All right, I'm going to look here. What could I take out of both of these first 2 terms? I'm going to pull out an x squared so that this is x plus 6. And then in this second one, I'm going to pull out a 10. So then I have x plus 6. All right, notice that these are the same. All right, so I'm going to write that in my answer, x plus 6. And now I'm going to take my 2 things that I factored out, x squared plus 10. There we go. Not too bad, right? All right, let's look at one more here. Ooh, this one we have an x to the fourth and an x squared. Okay, I know you guys are factoring pros from our last unit. All right, in this way, we do just like you were factoring last unit. All right, so I might teach it a little differently than your math teacher did, but here's how I like to do my factoring. Okay, I like to draw a big X. We always multiply to the top, add to the bottom. We always multiply to our A value times our C value, and we add to our B value. All right, so in this case, my A value is 1, my B value is positive 10, and my C value is that 21. All right, so we want to multiply to A times C. So 21 times 1 is just 21. And we add to our B value, which is 10. All right, so now I'm going to start thinking of some factors of 21. So 1 times 21, 2 doesn't work. You could do 3 times 7. Oh, wait a second. Check this out. 3 times 7. 3 times 7 is 21. 3 plus 7 is 10. So therefore, I can write x plus 3, x plus 7. As my two factors. But watch out, this was last unit, okay? This time it's x to the fourth power and x squared. Okay, so we just have to make these x's squared. As long as we make those x's squared, then we're good to go. All right, so these were our factoring problems that were 5, 6, 7, and 8. And I believe that's it for our review. So hopefully this video is helpful and you can use this to help you study for that retake. All right, have a great day, guys.